All right, welcome to the first example for section 3.5. In this section, we are going to be looking at solving nonlinear systems. So when you hear nonlinear systems, let's think about what that means. So remember, systems means more than one equation. So here in our example, we've got two equations. And linear means, right, first degree equations, so no exponent, and the graph is a straight line. So a linear system, those are what you've done before in Algebra 1, where you've had two linear equations, so two equations that look like this one right here, and they have an x and a y in it, and you solve those using either graphing, substitution, or elimination. We did solving three variable systems earlier in the year. A nonlinear system means that we've got at least one or both of our equations are quadratics. So if we graph these, they would not both be straight lines. So that's what a nonlinear system is. It's more than one equation with at least one or both of them are quadratic or nonlinear. So just like you did in Algebra 1, there are three methods to solving these: graphing, substitution, and elimination. So we're going to look at examples of all three. So the first one we're going to check out is solving by graphing. Now, if you remember, in Algebra 1, when you solved by graphing, let's say you had your, let's say this is one of your lines right here, and you had your other line right here. Okay, these are the graphs of your two lines. You looked for this point right here, the point of intersection. And whatever the coordinates were at that point, that was your solution. Okay? So that's how you use graphing in linear systems. You graph both of your lines, and the point at which they intersect is your solution. That's the exact same method, that's the exact same process that we're going to do here with our graphs. Except because we've got a parabola, they might intersect at more than one point. So we're either going to have a graph that intersects at 0, 1, or 2 points. So just remember, just like with quadratic equations, you can have 0, 1, or 2 solutions. Same thing here. We can have 0, 1, or 2 points of intersections. So we want to go ahead and graph these. So what you need to do is plot both of these out. Now, I'll do a couple reminders on how to graph quadratics. Remember, in order to graph a quadratic, first thing you want to do is find the vertex. And we look at this. This is in standard form. So we're going to do y equals negative b, or x equals negative b over 2a. That's going to give us our axis of symmetry. So here we've got negative b, so that's going to be negative 2 over 2a. In this case, there is no coefficient. A is equal to 1. So it's going to be, here the negatives are going to turn into a positive. So we get 2 over 2 times 1 is 2. We get 2 over 2, which is 1. So our axis of symmetry is at 1. Now, to figure out what our y value is, we just plug 1 in for x. So we're going to get 1 minus 2 times 1 is 2, and then minus 1. So we get 1 minus 2 is negative 1, minus 1 is negative 2. So our vertex is going to be at 1, negative 2. All right? So when we go ahead and graph this, we know that if we go down here, our vertex is going to be at 1, negative 2. Now, our axis of symmetry is going to be this vertical line that goes down through it. Now, when we try to graph the rest of our parabola, we want to plug in some extra points to get the rest of our graph right here. Okay? So remember, since we know that the vertex is at x equals 1, we want to pick 2 points to the right of that. So we'll pick 2 and 3, and then 2 points to the left, 0, -1. So we already know our vertex. Now, let's just go ahead, because we know of our rules of symmetry, if we plug 0 in for x, we're going to get -1 for y, because we get 0 minus 0 is 0 minus 1. That means that we're also going to have -1 or -1 at x equals 2. And let's go ahead and plug in 3 for x. We get 9 minus 6 is 3 minus 1 is 2. So we're going to get 2 for these points. So we know if we go one more point over, we're at 2 right here. And same thing, if we go, that's -1, we have a point here. So our parabola is going to come down and go through these points and look like this. Okay? Now, for our other equation, we just go ahead and we plot our y-intercept, which is at -1, and it has a slope of -2. So down 2 over 1, up 2 over 1, up 2 over 1. So here, if we go down like this, in this case, our point of intersection looks like it's right here at the y-intercept, x equals 0 and -1. And this is kind of a rough, my graph right here is obviously kind of a rough draft, but I wanted to go through the process of actually graphing this for you. So let's look at the graph that they actually have right here. This is the nice drawn out graph right here. And you can see that just like we graphed, our point of intersection is at 0, -1. And that's going to be our answer for this. Now, to check your answers, you can always go back and plug in your values. So plugging in 0 for x and -1 for y, you'll find that if you plug that in, you get true equations, true statements in both. So they end up working out. If we plug 0 in for x and -1 for y, sure enough, we get true statements. That's how you can always go back and check your work. You can plug in your solutions and make sure that you get the right answer. So that's how you solve this by graphing. Now again, what I went through here were the steps as a reminder on how to graph parabolas and how to graph your linear equations. In the next two videos, I'm going to show you substitution and elimination. But this first one is just how to solve by graphing. So just to have you practice this, I want you to go ahead, follow the same methods that I did. I want you in your notes to plot both of these out. So go back through the video if you need to rewatch and find the vertex and then your axis of symmetry and find 2 points to the right and left of your parabola and plot your line. Go ahead and find the point or points at which they intersect and go ahead and answer the question that pops up now.